Hello guys, let's solve the problem perfect squares. Okay, so in this we have given a number n and we have to find the minimum number of breaks in which we can have to use a perfect square to make the sum. Okay, I could clean this up. Okay, suppose I have a number 12. I have a number 12. So, how can I break this? I can break this in 1 plus 1 plus 1 till 12. Okay. All I can do is not 2. I can use 4 plus 4 plus 4. Or how can I break this? 9 plus 1 plus 1 plus 1. Okay. These are the three ways in which I can break this into a way. But the thing is, I need a minimum number. In this, it will take 12 breaks. In this, it needs 3. In this, it needs 4. So, which is minimum? This is minimum. So, I have to return this number of breaks. So, how can I solve this? There are two ways. One is dfs and one is bfs. Okay, the bfs is more faster than the dfs, but both return a same function. Let's first go for dfs. Okay, dfs. Suppose I have a number 12. Okay, then how can I break this into either 1 plus 11 or 4 plus 8, or I can go with 9 plus 3. Okay, so this is my number that I did to break. Okay, this is the square. Now, 11 can be further divided into 1 plus 10. Okay, or I can go for 4 plus 7. Okay, or I can go with 9 plus 2. Okay, and this 1 is the square, 4 is the square, and 9 is the square, and I have to make the difference for this, and this, and so on. Okay, now suppose I have 8. 8 can be divided into 1 plus 7. Okay, or I can divide this into 4 plus 4, and I cannot divide it into 9. 3 can be, how can we divide? 1 plus 2. Okay, in which 1 is the square, 4 is the square, 1 is the square. So how can I further divide this 4? 7 can be further divided into this call, and this call is same. Okay, so how can I divide this 4? 1 plus 3 or just simple 4? This is the main way. And how can I do this? So what is the minimum path I can traverse? Minimum thing I can do is 12 to 4, 8, then 4, 4, then 4. So it is 3. Okay. This is the main TFS 3. And then this TFS can be further optimized to DP with the help of memorization. Okay. And this can be converted into CP. So let's code this up. You got the path. How can I do this? So let's start. I need a function called dfs. Okay, which I'm going to send the value. Okay, and I'm gonna return dfs. So let's solve this. If we write the base case. If 12 equals to 0, we're gonna return 0. Okay, now suppose if 12 is less than equal to 0, then that what I have to return. I can return -1 because it will decrease the value. So I have to return higher value. Let's suppose I can go 10k or 7. Okay, this is the base case. So I need to find all the squares to make a rest. Rest period and yourself. No. For I in range, 1 to square root of uh, um, into, square root of well plus 1. Okay, this is the simple for loop which I'm going to traverse to find all the squares. So, what are the squares? Would be I into I. Now, if the thing is, if well is greater than x2r, then we have to break. But the thing is, we are always doing this in this, so we cannot. This is of no use. Let's simply table. Less equals to minimum of s comma 1 plus I have used this square root, so I have to include one step, one data. Okay, 1 plus again a dfs call in which we will simply minus square, the square. Okay. Now it is simple. We gonna turn the s all that. Let's run this. Yeah, software is running. But thing is, it will give a TLE because it is we are using repetitive calls. We are breaking 7 again and again, 7 again and again. Okay, so we'll return to TLE. So what can I do is get submitted or TLE. So what can I use is do a memorization. If well in dp it turns dp well means if I have already calculated the breakdown of 7 here, then why I have to break down of here? So I'm going to put dp this. Now let's sum this. Just a 3-line of code can increase the time complexity, decrease the time complexity, and submit it. Okay. Now the thing is, the DFS is taking a long time to traverse. Again, a long time taking. So what can you use this? Use the DFS, BFS. Okay, BFS. The thing is, when we have to find the minimum, okay, or something that is taking, so we can prioritize it BFS. Okay, suppose I have to find I'm here and I have to find a path to here. Okay, then or which is the minimum steps to reach this? Then I will go for BFS. Now, if I have to find all the paths till here, then I will go for DFS. So, this is the thing. So how the BFS work? Suppose I have a well, I have an n value equals to 12. Okay. Now suppose what are the square roots? What are the square we can have inside this? 1, 4, not 2, 4, 9. These are the all squares that belongs from 1 to 12. Okay, so what are these? Okay, so what can I think of is I can just simply make a queue. Okay, making a queue. In which I'm going to put 12. Now, while I'm not getting, the thing is, I will not break until and unless I got this in a value this equals to a q in value. Suppose I have 4 here and I have also 4 here. Then I'm going to break. Okay. This is the base break condition. Now suppose I have 12. I'm going to pop the 12 and I'm going to minus all of this. So 12 minus 1, 11. 12 minus 4, 8. 12 minus 9, 3. Okay, this is popped. So I'm gonna erase this. And I got these values. Okay, now, now I'm going to use a rest value in which I'm going to tell how many steps I have done, how many loop I have done. Okay, I have done one. Okay, now. Second, I will pop 11. Okay, now I'll minus all of this, then it will be 10. Okay, 7 and 2. Okay, this is one iteration, this is second this is going to be all the second iteration. Okay. Now I'll pop 8. Okay, 8. What would be the result? What would be the result? 8 minus 1, 7. 4. And I cannot minus, so I will just put an empty here. Okay. No. I will pop 3. Okay. 3 minus 1, 2. 3 minus 4, I cannot do this. Okay. So this is one iteration. So I had done the second iteration also. Okay. This is one iteration. This is second iteration. Now I'm in the second iteration. So let me just clear it for you. Drag all that. Okay. So I got this value. So now again. So this is my second iteration. So I will just again pop the 10. And I got some values like 9, 6, 1. Okay. Now 7 would be. Wait. Now I got a 7, so I can just simply put the 6, 3. Okay. Now thing is now again I'll pop these two. Now again at 2. 2 will not give a 1. Okay. Then 7 would give again these three values. 2, 3, 6, which I'm going to copy and paste again. Okay, suppose this is the value and I got the answer now. Since I moved the 4, I will get 4, then I will have 3, 0, and okay, since I got the 0, I will just break down and return the rest value plus 1. Okay, this is the main concept behind it. Right, I took 3 steps, 3 iterations just to find minimum break. Okay, let's code this. Okay, let's code this up. Okay, so let's create find all the squares that are between 1 to n. Okay, for I in range of n plus 1. Okay, okay, so let's do this. The SQR would be found to let's make it as if SQ is greater than then else append SQR dot append what the square. Okay, I got all the squares, all the perfect square that lies between 1 to okay, but n is included and 1 is okay. Now let's make a cube. Q equals to the cube. Okay, now I have to append. Good. And okay. Um. So now in this box, not pen. Okay. Now, let's activate while Q. Okay. Now let's find the red. Okay. And I'm going to find it. Okay, this is the iteration, and I'm going to return this, and this is the steps. Okay, the break. Okay, so I'm going to on each iteration I'm going to increase one rest. Okay, now I have to pop the value. So value equals to q dot pop left. Okay, now for I in SQR. So I'm gonna q find the temp. Temp minus I if temp is less than 0, then continue, else what I have to do is print in the queue. Okay, so I'm going to this is the for loop for this iteration, that 4 3 4 to 3 4 to 0 4 to 90. Okay, this is the main iteration. I'm going to pop the values, and if 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 temp temp equal to 0, then return just this one. Okay, let's run this. Okay, I'm going to just print a stress, but because I'm putting the test in this and submit this. Yeah, it's perfectly running, and it's literally less time taking as compared to the previous one which was here. The BFS is much faster. So yeah, that's all for this video. I hope you understand this. If you understand this, give a like. Okay, thanks.